Richmond, let us know if you can hear us and see us. By the way, that's group by.
Can you guys see it behind?
No, I'm going to try to refresh it.
It still doesn't want to be front.
So if I said group by order ID and group by date, can I say select order ID, comma average price?
No.
I don't have to. It's misleading to do that because really it's going to report, let's do this. I just taught you how the optimizer figures out how to do groupings. Walk me through and tell me what the results are going to be, as if you were the computer.
So first it's going to go through and group them by order ID. So you'll have
And date at the same time.
At the same time.
At the same time. That's critical. When you have multiple columns, it's going to look at unique combinations.
So your different combinations would be 1 and 3, 7. Your next one would be 1 and 3, 9. And there are 2 of those.
So you got 3 records, and it's going to be those unique combinations. So it figures that out first. Then it says, okay, you want to see order ID. Well, so you're going to have 3 records. It's going to be that. Nobody's going to understand why you have 2 1s there, because we didn't put the date in the output. But hey, you didn't want the date. It's going to respect whatever you asked of it. So it usually doesn't make sense to say group by order ID and date. Do y'all have the feedback there, by the way?
Yeah.
Good. So it usually doesn't make sense to say group by field, 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 and then not have in your output. You can do it, but it doesn't make a whole lot of sense unless you have some special output. So order ID, let's continue to do it wrong here, and then we'll add the column to fix the query. So we've identified these are the unique combinations of order ID and date. And we still want, let's make it simpler, because average is a simple sum divided by count. So let's make it sum, which is another aggregate function. It works exactly the same way, just a different number. Okay? So order ID, comma, sum price. So we found the unique ones, and it says, okay, sum of price. That's what you want to do?
3.
3. I'm going to sum 3 with itself. It's just 3. There's only one of them. Nothing to sum. Got another unique value? 4. Okay. There's only one of them. Nope. There's actually 2 of them. It's 4 and 5, isn't it?
9.
So when does it come up? How does it know they're 9? Think about it. Internally, it's going to go through and it's like, okay, I found a unique value. Done. Throw that out. We got that result done. I should actually choose the second one, because that's when it realizes it's done. It says, okay, I've got a new one. I got a 1, 3, 9, 1, 3, 9. I don't care. And it threw a 4 into its basket. It threw a 5 into its basket, and we're summing it, so it's got 9. Now it goes to the next one. It's up 2 doesn't match what I just looked at. Write that out. I also need to write out my sum. So when it realizes that it's going on to the next distinct grouping, it writes out the result of its aggregate function. Now this doesn't make a whole lot of sense, because you have 2 1s. Why is it? Because I didn't put date in there, and we're grouping by date, but we're not showing it. Now let's go down here. And instead of this one, let me show the second one. So it says 2. You clear out your basket. You empty your basket. It's like you roll your basket of apples onto the floor and clear it out every time you go on to your next grouping aggregate function. So we're empty. First thing we're going to do is, like, here's a new distinct one. Put a 3 in there. So I got a 3 in my basket. Next line, I've got a 7. I'm going to add them together. I'm going to get a 10. I'm done. Time to roll my basket. So you'll get that. You get 3 results because I said, give me a group by order ID and date. It doesn't make a whole lot of sense to see it like this, but you need to understand why it's doing that. Grouping by says group by distinct combinations of all of the columns I'm listing. Question?
So is it better to keep group bys more simple? Because it seems like the more things you try to select when you have a group by, the more complicated it is to read. Or at least make sense out of it.
The question was, should we try to keep group bys simpler to make it easier to read and understand? Sometimes you can't avoid it. You know, it's another tool that you can use. Use it at your own leisure, however you want to use it. There are other ways, not too many sometimes. Sometimes you have to use a group by. It's not often in the real world where you group by more than 2 or 3 columns. Because if you think about it, these are categories. It's like on a screen where you have a hierarchy, and it's like, first this is distinct, and then that's distinct, and then this one. Humans don't think in hierarchies like that, more than 2 or 3 levels. Usually it's like, okay, here's a good one. Give me the annual sales reported by month. Okay, you're going to group by month. That's one group by. And you're going to have a sum of price or sum of revenue. It's that simple. Most of the time, your group bys are like 1 or 2 columns. So how do I fix this so it actually makes better sense? So I can actually report. And somebody explain to me in English what these results mean. So then, by the way, what are my results going to be? What's the middle column?
Date.
Oh, what is it though?
739.
Okay. Hopefully this elucidates that when you say group by, it's all of the column combinations. So I have 39 twice, but that's because I've got a different order ID. It's a different combination. Somebody tell me, without going through the full example, if I said select order ID, comma, sum price. What's that again? This is the data.
Just select order by ID, some price.
Yep, what's the answer?
It'd be 1 and 2 are your left-hand sides, and then it's 5 for 9. It's 12 for 1, and then 10.
Good. So that's how grouping works. Grouping says, I need to make all of the columns, all of my bare columns that are not in an aggregate function, I got to give it to you, and they're all going to be distinct. If I had another one, first name. It doesn't matter. First name. Can I say first name up here?
Sure.
Well, it's not my group by clause.
No, that shouldn't be.
Oh, it's not.
Yeah. If you don't group by it, it's not going to allow it in your select projection. It's going to say you cannot. It's some cryptic error that says you cannot include a field in your projection list unless it's also in your group by if you have a group by query. Because it didn't know what to do with it. It goes through and it's like, well, what do I do with first name? You list it up here, but it's not in here. You could put it inside an aggregate function. What's an aggregate function you might be able to use on a string?
Is concatenate considered an aggregate function?
Nope. What are your aggregate functions? What are some of the other ones?
No.
You could do a count. Like, give me a count distinct of first name. You do that. Max. If you're doing a max on a string, what's it going to give you? Alphabetical max. Min, alphabetical min. Yeah, you could do that. It doesn't make a whole lot of logical sense, but you could do it.
What does that mean? The least letters?
No, it's going to be, it's going to sort it, and then it's going to say, give me the first one. Like, A, aardvark probably would be the first one.
Alphabetical.
Is parse considered
Nope. There are very few aggregate functions. And here they are. The ones that you really need to know about. And
So, gotcha.
Oh, do we have it? We have it?
no, this is just notes, things I need to cover today. Okay, so your where clauses. Here are all the possibilities of what you could do in a where clause, in your conditionals. Tell me if you don't understand what one of those mean. You got an equal, that's straightforward. You got a greater than, you got a less than or equal to, greater than or equal to. Okay, these two are the same. That means not equal, and that means not equal. It's just however you want to write it.
What is the difference between null and exists?
Okay.
Null is the absence of a value. Is exist
For a field. Okay, so the question was, very good question, by the way. What's the difference between exists and null? Or is null, is not null? For null, is null or is not null, you're saying, does this field value equal null? Exist says, do you have one or more rows resulting from the query? You're not looking at a field value. You're looking at the results of a subquery.
Okay. Can you give us an example?
Yeah. Let's say in Sakila, let's show me all of this. How many stores do we have? We only have 2 stores. How many? Okay. Let's see if there are any films that have no rentals. So how do we do that? There's a rental table, I believe. Yep, let's start with the easy. Select. Halfway there. So from. And the challenge is this, to repeat it for everybody's benefit, including my own. We're trying to find all of the films that have no rentals.
So let's look at all the films first. Did you select star films?
Yeah, but we know they're there. We want to find where there aren't any rentals. So we need to go look at the rental table. There's a staff, there's a customer, there's an inventory. So one of the things that you'll learn about relational databases is that the relationships that you think would be simple sometimes are not. So there's film ID and there's store ID. So we just have a 3-table join rather than a 2. So we're going to join film to inventory. On and we also have to go to rental. Now, we could do a select star there, but we know we're going to get results. And we haven't actually answered the original question, which was, let's see if there are any films that have no rentals. I'm going to show you 2 different ways of doing this. And this is actually on my list. It was one of the advanced topics down here. Abusing a left join to ensure lack of existence.
No.
Okay, let that sink in for a second.
That probably won't work, right?
We could make that a left join too. That'll work, yeah, that's valid syntax. What am I doing here? I'm saying I want to join, but left join. And the way it's written, it says, I want left join, film, and inventory. That means I want all the films. Don't even question the films. The films are always going to be included. But only include the inventory if there's an exact match based on film ID, which means you may not have a row in inventory. Since I've started with that, I can also say, extend that logic. It's like, okay, left join, this whole bit, what I just told you that we're going to have, which is all films and inventory if they exist, all of that, and, you know, if you have a rental, I want you to relate that one too on inventory ID. But then I come back, and this is where I throw you for a loop. So first let's do this, and let's see what the results look like. So it says, okay, all the way through we've got a bunch of rentals. Oh, down at the bottom we have some things that don't have any rentals. There's no inventory, and there's no rental. If you have this set, these are results, and you want to say, I want to see the films that have no rentals, you can say is null. Oh, show me this left join results, but I want to select the ones that are null for that column. So you see how I'm abusing the left join. I'm saying, show me just the films that have no rentals. Why? How did I do that? Because rental ID logically can never be null. It's a primary key on the rental table. The only way you'd ever get a null is through the left join. So I'm saying try to match it and find the ones where the match failed. Ask a question at this point if you don't understand that. This is more of an advanced, a lot of people who write queries don't even do it like this. But this is highly efficient because you're using indexes to join, and you're saying, I've got a left join results, just show me the things that failed the left join, because that's really what I care about in this instance. I see people like, I want to ask a question, but I don't even know how to ask it.
Yeah.
Kind of.
Let's follow this through step by step again. So, films, left join, inventory. Let's just run it piece by piece. Films, okay, I've got a bunch of Academy Dinosaur, and it's got inventory for the most part, but if you scroll down here, there's some, I believe, that don't have inventory. You know, select star is actually hurting us rather than helping us, so let's just look at the keys. That'll tell us the truth of what's going on. Okay. Inventory ID is a primary key column on inventory. How is it that I'm getting nulls in that? That's the key to this. How did I get nulls in a primary key column in my results? There's no inventory record to match. And I said left join, so I said film 801, it exists, but there's no inventory for it. That's all it means. It doesn't mean I put a null in my primary key column. That just means my select results show a null in that column. Because I said left join. I said include the film even if it doesn't have inventory. Let me simplify this. Let's throw away the rest of the query. And if I said this, I'm doing exactly the same concept. There are 42 films that have no inventory. And if you don't have inventory, rentals depend on having inventory, so we know we already got the right results there. We're just being more restrictive and saying, oh, you also have to have a rental, even if you have inventory. So understand this, not my first one. Ask a question here if you can.
Wouldn't you want to kind of expand this out to list what the name of the...
Yeah, I'd probably want to see, instead of film ID, let's see like the title. And in this case, we probably don't care about seeing anything. This is another advanced concept. We're using joins to get our results the way we want them, but we're not showing any of the results from the other tables. We're using it to filter our data.
You could draw a Venn diagram. That might help.
Yeah.
Good
So
point.
I think I was getting lost with the two left joins because the way I see a left join is it usually goes here in the middle all the way over. And then when you throw in a third left join, it ends up getting this and all of that.
Yeah, I kind of imagine it as the first one is totally predominantly enabled, so
Right.
Blake had it exactly right. Whenever you're doing these, you never take more than 2 entities at a time. Joins only ever happen between 2 things. Okay? So in the first, we're doing film, left join, inventory. Let's do that first.
Yep.
Film, left join, inventory. Let's draw it. So film, that means I'm going to include everything here and all the matches from inventory. If you don't match an inventory, leave it out. But I said left join, so include everything from film. Step 1. Now, I get results from that. So I've got results 1. Now we're going to take that to the next step.
Okay.
So you only ever do 2.
Gotcha.
You get the results from this, and then you join that again, a left join to rental. So we're going to do rental.
So it only does it, so it's like a double filter on it.
That's how this is working. This is a 3-table left join, and so on.
Gotcha. Okay.
So to break it down, don't be afraid of a 10-table join. You're only doing 2 tables at a time, ever. But if you're at the 3rd or beyond, you've got to think about what your results are from the first 2, and so on, and it builds up. So getting back to this, let's write it the way we had it a minute ago. So I first did film inventory, keep all the films, throw in inventory if you got it. Then I'm doing left join to rentals, which means whatever the results were, now go see if the inventory had a rental as well. If it didn't, I want to know about it. How do I know about it? How do you look at the results? You can look at a primary key column that cannot logically be null and say, show me the nulls. You're saying, show me where the left join failed. By failed, I mean where the left join didn't find anything for that table. And that's actually answering our question here, which isn't your original question, which is, show me an exist. So how do you write that a different way? Here's another way to write that.
No.
It's easier. So this is one way, where not exists. With a correlated subquery. Here's another complex term, but it sounds a lot worse than it is. Rental where inventory is equal to that. Yeah.
So when you have an exist, you always need a correlated
No.
subquery.
In this case, we do.
Yeah.
What in the world am I doing with the select one? If we're doing an exists, you never look at the column output. So why do you need to even fetch it? I just say the number 1, because as I said earlier, exists looks at the existence or absence of rows. It doesn't look at what's inside the rows. So if I put a 1 in that row, if I do this, it's going to give me a bunch of 1s. But I'm still going to have the row, which is all you care about for exists.
And then ones, like if you were to scroll down,
Oh.
that would give you the nulls, right? You would eventually-
Well, I just selected that little bit right there. So that's going to give me a number 1 for every rental in the database. But what is this doing? This is the interesting bit. We've learned about a subquery just briefly. A subquery says, I've got a paren. I want you to run this little query. And I'm going to do something with it as part of my main query. How is it correlated? So we understand subquery. Correlated, what does that mean in English? It means it's kind of related. You got to match. Well, how are we matching here? Let's look at our table aliases. There's r.inventory ID. Uh-oh. That is the correlated. That says, I doesn't exist in this little query. I exists out here in my main query. We're correlating the results of this subquery, which is why it's called a subquery. Think of this as like a little parameter. This is coming from your main, and you're correlating your subquery results. So you're passing a parameter from here into here. set logic, it's not happening row at a time. This is where those of you who get set logic is like, okay, I get what he's doing. Those of you who don't like set logic, you're going to be lost. You can practice, you're going to get better, but it's not going to make sense to you when you first see this. Because you've got a set, and you've got an outer set, and this correlated means, think of it as like an inner join. It's like, I'm going to run this only where that's true. And then it says not exist. Then it says, okay, take the results of that, and logically, jump back to you, so you can ignore what's in this little black box there. It's like, okay, that's either going to resolve to a true or false. I'm either going to have rows or I'm not. And then you can do that as part of your where clause. It resolves to true or false. So there's your 43 rows. Again, exactly the same results. There's multiple ways to get to the right answer in SQL. It just depends on how you like to think.
Okay.
So exists is not null. Exist says, do I have at least one row, one or more rows? Not exists means 0 rows. What's another way to write this? You can do that. It's slightly less efficient, but it's never going to hurt you. That'll give you the exact same results, 43 rows. It all depends on how you think, which is liberating, isn't it?
That's saying count everything from the rental where your inventory ID is, which takes it out of the subgroup. And then if that equals 0, which means that
There weren't any.
there weren't.
Not exists. Not exist is slightly more efficient, because here you actually have to run the query and get like, oh, there's 3, there's 4, there's 7. Exist says as soon as it finds 1, I'm done. It skips it.
If you're doing not exist, though, doesn't it have to run through the whole thing?
I believe it does an exists to figure out if you have 1, and then it uses that. But I'm just guessing. Okay, getting back to, I know this is, okay, post the SQL. Questions? Okay. Richmond, any questions? Y'all missed some of the group by introduction. It's important to understand grouping. It's important to understand where. What is where used for? Filtering width or height? Height. The rows. Where is for filtering rows. What's another keyword that you can use to filter rows? Having. Having. What's the difference between having and where?
Having you can use along with, the group.
Yeah. Having is what you have to use. So the basics, here are all the different pieces of a select statement. We've got a select, columns, from, you can do joins or a table, at least one table. You can do joins here if you want. Where, and this, one person had a problem about the order of operations. SQL is very straightforward, but it's very insistent on which statements come in precedent. You can't put a group by anywhere in your statement. It's not going to work. You can't put a having up next to your where. Not going to work. There are certain things that have to come in order. If you have them in the statement, you can say where, do all your where conditions if you want. In this, you can have parens, you can have ors, ins, exists, is null, whatever you want. Where. Select from where. What's the next one? If you have a grouping, okay? If you want to use the results of your grouping, say you've got an aggregate column of a count or a sum or something like that, and you want to filter on that, you have to use a having. That is the only time you need to use a having.
What? I'm sorry.
It allows you to use the result of an aggregate function. So if like the sum is greater than 1,000, because the grouping happens after the where. Having happens after the grouping. So if you want to look at the sum or the count or the standard deviation, you have to process it with a having. It's not often that you use having, because how often you actually look at the count? Most of the time you're looking at the actual column values, which is the where. Then we're missing one at the very end, order by. That's it. That is an entire language summarized. Okay? If you learn nothing else about databases, understand here are all the options that you can do with the SQL select statement. Because 90% of the time developers are doing SQL, they're writing select statements. Now I've taught you a little bit about subqueries, correlated subqueries. What's the difference between a subquery and a correlated subquery? Subquery is just in parens, but a correlated means, oh, there's a parameter passed in from the outer query. That's all it means. It means you're kind of filtering the inner subquery. So it's a big fancy word that you might get asked about in an interview. Correlated subqueries. You know how to do those? Yeah, I got it. All it means is a little subquery, and you're filtering it based on the outer query. There are some other things out there that you don't need to know about right now. But I've made a list of them. I'm not one to hide knowledge from you. So, here we learned about that one. Here are some other things that, if you're interested, and this is in today's agenda, this is the internals of how the black magic really works for a SQL Server and PostgreSQL and a couple other database engines. Join multiple times to the same table in a single query. Why in the world would we ever do that? Say you have an order, and you have somebody who packs and ship it. Okay? Say you're in FedEx, and FedEx is going to be shipping out this widget to you. So the person who picks it may or may not be the same person who packs it, may or may not be the person who ships it. You probably have 3 columns. So 3 columns, all foreign keys from your package table. Let's call it a package table. Each of those 3 columns relate to probably what table? Probably an employee table or a user table. So all 3 of those columns relate to the same table. How does that look? So our theoretical structure looks like this. I want to see, give me the name of the person who picked it, packed it, and shipped it. So we've got a package table. And it may or may not have been packed or shipped. Do we use an inner or a left? A left. Left means it's fine if you don't have it. Just because it hasn't been picked, I still want to see the package. Now, I'm not doing this to make you feel bad on the end of the day. I'm doing this to show you that there's a lot more power out there, and you already know how to do it. You just need to know how to assemble these tools in the right order, and you have a lot of skills that you didn't even realize you had already. It all comes down to what's written on the board behind me. It's all that same structure. Now it's just mixing and matching the tools and understanding the relationships. The one-to-manys, the inner join versus left join. So I have 3 copies, and I should say copy here, of the employee table. And that is commonplace. You'll see that all over the place. You need to understand what in the world is going on here. So you have one table that's a child 3 different times to the same table. Because you've got a picked by, packed by, and shipped by that could be different people. But all of those people are going to have their reference on the employee table. So you need 3 different copies. How do you do that? You have an alias. E1, E2. Ah, that would have been bad. Bless you. That would have been bad because SQL wouldn't have complained. It's like, okay, that's a weird join, but I'm going to let you do it. That would have been logically a problem. It wouldn't have come back with the right answer. Bless you. How many people understand that?
Shouldn't be a left join underneath on the last line.
Yeah, I need to say join there. Okay, I'm going to paste that. Stare at that for a while.
Absorb it.
Ask questions about what in the world's going on. Think of it as 3 different copies of the employee table. Okay? So John, Mary, and Mike. 3 different people, but you're joining them against a different column. That's the trick. After I showed you that, probably there's going to be no takers for any of the other stuff, right? It's like, please, no more. Okay. These are just special statements that you can do some interesting little tidbits with. There are some functions, but I think it's time for you all to go back and continue with the practice for the rest of the day. I want you to go write, finish up the examples, finish up the challenges, and I think we were on... Oh, I misspelled Venezuela. So here I said, give me your top 5 customers as long as they have rented 3 or more times. That rented 3 or more times is probably going to be account star, right? If I'm going to filter on account star, what statement will I need?
Group by.
Group by will allow me to do the count star, but if I'm going to filter on the count star, I'm going to do a having. A having because the group by is going to give me the count star, and then I can filter on it after I've got it. Let me give you that one.
So I did this one a different way.
Oh, good. I love to see different ways of thinking. So Scott said, that's nice, but I did it my own way. How did you do it?
I did 2 different queries, or 2 different select statements. The first one was just going to be seeing if there were any that had less than 3 orders. And when there weren't any,
How did you connect them?
I just did 2 separate ones. And then realized that there weren't any and took that part out.
Okay. So he
that
solved it with 2 separate queries in sequence. That's fine. So any other questions before we go back? Richmond, any things we want to cover before we go back to writing your own?
Harper had a question. He wants to know if there's a way to do a join and subquery where you can use the on to filter.
Join and subquery. We can use the on.
What's in the questions? You scroll up a little bit.
It's after the thumbs up on the top. Yeah, it's right there.
Okay, is there a way to do a join and subquery where you can use the on to filter? Join and subquery. Let me see if I can figure out what it's being asked. So, like the on clause here, on I'm not sure what's being asked there.
Now you say so select like all from table.
Inner join. Oh, he's talking about, the technical term for that is a derived table. We need to understand how to do that too. And you'll actually, I'm not gonna curse you to pound your head against the wall later on this evening. Let me give you this one. Okay, this is what he's talking about. You see that paren? You can do a from, and this looks like a subquery, but it's not a subquery because it's part of the table that you're querying from. You've heard about a view. A view is nothing more than a stored query that you can treat like a table. Think of this as like an inline view. So the way you read this, just like parentheses in every other circumstance you've ever seen them, do what's inside the parentheses first. So run that, and you can actually run that by itself as a completely separate query. You get your results, and then you can use that to join to other things if you want. Or in this case, why did I do it? Because I was pre-calculating. I want to see the date diff, and I want to do some math, and I want to calculate those as virtual columns. Then I'm going to use those virtual columns up here to figure out, now that I figure out the day is late, step 2 is, let me look at the case. Case is like an inline if-else statement. When day is late greater than or equal to 6, then 12. Else, when day is late greater than or equal to 3, that. In all other cases, $1.50 times days late. What in the world was I thinking here? So the first and second day late is charged at $1.50 per day. So the case statement syntax is that. Case, when something, then, all the way to end. All of that as a virtual column. So in this case, this is what's called a derived table. Think of it as an inline view. Think of it as a virtual table that you're building with the result of your select statement. And you can use it to join to other tables or aggregate or do whatever else you want. So this is where hopefully you're starting to peek behind the curtains like, oh, this could get really, really complicated. Yes, it can, and it does. But the beauty of it is it all comes back to what's written on the board. If you understand that, you won't get lost when it gets more complicated like this. There's really nothing different. You understand this is like a 1, 2, 3, 4 table join. This is a simple where clause. This is a date function that says, give me the difference in days between rental date and return date. This is a greater than or equal to. This is a column alias. The only thing new here is this. You probably didn't know that you could have, give me all of that as a virtual table. And then, ignore that. I'm going to do select from that. What is this? This is a table alias for that. So if you break it down, it's not too crazy. Probably crazier up here is the case. Cases where that's like an inline if-else statement. That's about as much logic as you can do in SQL. So the good news is that's about all you get in SQL in terms of a select logic. It doesn't get more complicated than case, normally. Now, that I believe is the hardest one I gave you. And I didn't intend to give you that hard one. Go back and do the rest of them. And if you have questions, raise your hand.